Hello class, welcome to Unit 10, Lesson 1. Today we're going to work on finding limits numerically as well as graphically. In order to find it graphically, you want to make sure you go ahead and grab your calculator. So you're going to need your graphing calculator. So today we're going to use a table to find the limit of a function, and we're also going to use a graph to find the limit of a function. So what is a limit? A limit is a value that the function approaches as we focus on a particular x value. Okay, so if you see x is a right here, so we are saying I have a curve and we want to see what it looks like as we get close to a. So my curve, let's say it looks like this. Okay, there's my curve. And we're going to say as we get close to a, from the left-hand side and the right-hand side. Okay, we follow along the curve. What is the y value? Okay, so in this case, we're going to call it L because it's saying the answer is L. So what it's saying is you follow the curve along from the left and the right, and if they meet up at a point, that is your limit, okay, from the left and the right. The biggest thing is that your final answer is always going to be a y value, okay, and the way you would read this is the limit of f of x as x approaches a equals L. Okay. So we're going to be looking at curves. So we're going to use tables today to go ahead and figure out, well, what are the points as we get closer to A and what are the points as we get closer to A from both sides, so left side and right side. So our first little example, we want to find out this limit as you approach 1. If I plug 1 into this equation, okay, if I put in the bottom, I'd have 1 squared minus 1, which gives me 0. I would really have 0 over 0. Can you divide by 0? You cannot. And so that's where the problem occurs. So in order to actually calculate the limit, we look at x values that get really, really close to 1, but actually aren't 1. Okay? So I do it from the left-hand side and the right-hand side. So I might have some curve, and we're trying to get to 1, and so I pick numbers just less than 1. So I'm like, oh, 0.9 is really close, then 0.99, then 0.9999. So I could just be getting a little bit closer to 1. Same thing from the right-hand side, I might check it out from here and to get a little closer. That's why I picked these values. So if I said find the limit as x approaches 2, you'd probably be like 1.9, 1.99, 1.999, and then I would do 2.1, 2.01, 2.001 to get closer to our x value. Okay. So there's a nice way we could do this. We could actually take and plug each one of these numbers in, or we can go ahead and use our calculator. So we're going to use our calculator, more efficient. So we grab our calculators and we type in the equation. Okay, so the first thing we're going to do on our calculator is go to y equals. We're going to plug in the equation. Biggest thing with this is make sure to put the numerator all in parentheses. So we have x minus 1 divided by parentheses x squared minus 1. Okay, that's step 1. So maybe you want to make some notes. I'm going to make some notes on the calculator. First things first, enter equation. Okay, and the way you do that is at the y equals. Next thing we're going to do is we are going to go to our table set. Okay. Table set is right above window. So we're going to go second table set. So we're going to go second table set. And under table set, we're going to go ahead and we are going to change this independent to ask because we want to pick what numbers we want to put in. We want the calculator to ask us what we want, and so we're going to change it to ask. So we're going to arrow down and over to ask and hit enter. Okay, so we select, under the table set, we go independent, what that stands for, that's the x values, and we're going to change it to ask. Okay. Now that we've done that, we're actually going to go to our table and look at it. So table is right above graph, so we're going to go second table, and then from here you should notice it used to have a whole bunch of x values, and then it would tell you the y values. Well, now it doesn't have any x values. That's because it's asking us, what do you want to plug in? So we're going to plug it in. So we'd have 0.9. Then we'd have, what's the next one? We got 0.99. And we're going to write these numbers down to 5 decimals on our table that we are provided. I got 0.999. So I'm going to fill those in on my table. So I would have, what do we got? We had 0.5, I hope I copied this down right, 5.2. 5.2632. And then at 0.99, I think I had 0.5051. And then we had 0.50024. Sorry, 25. Then we're going to go ahead and do the same thing. We need to plug in the 1 values. So we have, we're just going to keep typing it in, 1.1. Enter. Then we're going to write that down. We're also going to do 1.01. Then we're going to do 1.001. Okay, and then we're going to write those numbers down. Okay, so now we have 0.47619, and then we had 0.49751, and then we had 0.49975. Okay, so we have these two tables here, and we're trying to figure out, well, what's happening as you get close to 1? So this is getting closer and closer and closer to 1. What number does it look like we're going to here? And if you look here, we're getting closer and closer and closer to 1. What number does it look like we're going to here? Well, I would guess that we're going to 0.5. So whatever it looks like we're going closer to, 0.50025, I bet if I did 0.99949s, bet it gets even closer. So if we had 0.12349s, so it's getting 0.50003. Or if I did 1 point, get really close, lots of zeros, enter that, it tells us 0.5. It basically rounded it to 1. So as you get closer and closer to 1, it's getting closer to 0.5. So my limit is 0.5. Okay. So we're going to use some tables today to kind of figure it out. But you'd look at these and say, well, what's happening? Where's the trend leading us to? It's leading us to 0.5. If I go ahead and hit graph, I'm just going to look at it graphically. I'm going to even zoom in a little bit if you just want to look at my screen. Zoom in, number 2. Okay, so as we were going to 1, okay, that's my x value. You can see that's right here. Okay, as we're getting closer to 1, what's happening to my y's? Do you see how my curve from the left and from the right is leading to 1/2, it looks like? Because this is 1. So it looks about 1/2. Yeah, so that matches up with our thoughts. So we're going to use tables. We're also going to look at graphs in a little bit. Okay, let's go ahead and do this one. Do a little bit quicker. The nice thing about this one is the table. They're giving you the values. So we're trying to find 9. So what we start with is numbers that are like 8.9, and then you get 8.99, and then 8.999. We're getting closer to 9. Same thing here. We have 9.1, 9.01, and then 9.001. So we're going to type those into our calculator, and then we're going to write them all down. So first things first, go to y equals, clear it out, and then we type in our new function. Make sure parentheses are around the numerator. So second square root x minus 3. End parenthesis divided by parenthesis again, x minus 9. And if you remember what we did, we actually don't have to go back to table set. But one thing I will say is if you want your table to go back to normal, you just have to change it back to auto. So we want it to be on ask. And then we're going to go back to our table. And now we're going to just type it in again. I'm just going to type over top. So we got 8.9. And then we have 8.99. 8.999. And then we have 9. I'm just going to type them all in and then write them all down. 9.1, 9.01, and 9.001. Okay, so you can kind of take a look. What number does it look like we're getting close to? Kind of going it for 9, which is in between these two. So I have 1.6667 and 1.6621. And if you look here, here's my 0.001, so we're getting 1.6666. So it looks like we're approaching this number if you look at our two that are closest to 9. But let's write them down. So if I copied them down right before on my sheet here, this was 16713. Then we have 0.16671. then 0.1667, and continuing on. Hopefully you kind of can write these down as you look at your calculator screen. I really hope you're using your calculator screen. And so, what does it look like it's getting closer to? We want 9. I would say 0.16 repeating. So my limit is 0.16 repeating. Okay, so there's example 2. Example 3, I'm not going to type into my calculator. I just want to talk about how you'd set it up, because the first few, some of the problems on your homework, I give you a complete table with the x values, but you have to find the y. Well, now this is asking for x and y. There's a few like that. So if I wanted to find out 3, as we got closer to 3, what would we need? Okay, well, we want numbers still left of 3 or smaller than 3. So I'd probably start out with 2.9. Then we would have 2.99. Then I would have 2.999. Okay, then I want numbers bigger than 3. So I'm going to go 3.1, and then I'm going to get smaller to 3. 3.01, 3.001. Okay, so those are the x values I put in because it's going as x goes to 3. Okay, so that is using a table. If you have questions about your calculator, feel free to let me know, but make sure you follow those steps and get to your table. Then we need to talk about limits graphically. Okay, we have one-sided limits. Okay, the limit as x approaches a real number c. Do you guys see how this has a positive? Okay, I always think that's coming from the positive side. Okay, I always think about the right as being positive. So as I approach from this side, we're getting closer to this. So the limit of fx as x approaches, the limit of fx as x approaches c from the right. The positive side is the right side. Okay, that's the notation from that one. So to be right side, if I was talking about coming to this point right here, if this is my constant c, from the right, I would be following the curve until I got to that point to find the y value. So it's our limit as x approaches c from the right. Okay, this would be then, c to negative, would be the limit as x approaches c from the left-hand side. The other thing I think, like if you could see my hands right now, this would be the left hand, my left hand, and this is my right hand. So my left hand approaches the curve. So you follow along the curve. So this is my limit as x approaches c from the left. Just think, this is your left-hand side, this is your right-hand side of your paper. So left hand gets closer to the point and the right hand gets closer to the point. One thing I want to point out, and it comes up in a little bit, but if I want to find the limit as x approaches c, that's actually asking you to find both of them, okay? The left-hand side and the right-hand side need to match up at c. The curve needs to come to here for it to be true. So let's look at an example. Okay, so the limit as x approaches 2 from the right. So here's 2. So I look at the curve, and this is my left-hand side. So I go to my right-hand side. I'm getting closer to 2 as I follow along this curve. So there's some really bad arrows. But as I follow along this curve, what's my y value? It is 5. As I try and find x as it approaches 2 from the left, that negative means from the left. Okay, here's 2 from the left-hand side as I come to get closer. What's my y value? -1. So left-hand side, right-hand side, but we're always coming to the x value of 2 for this problem. Now it's saying find the limit as x approaches 2. Okay, well, does my curve match up? One's going to -1 and one's going to 5. How would you know which one to pick to find your overall limit? Okay, there isn't any way. So this one, it does not exist. There's this little jump in between. It's a good sign that it's going to be a limit that does not exist. So DNE is what we write, but that's the same as this. Does not, and you can write it out if you want, but I usually would just write DNE, does not exist. Okay. So here's another one. Let's give it a try. This negative got a little low. 2 as x approaches 2 from the left. So here's 2. I'm taking from the left side. This is my left hand. This is my right hand. My curve is right here, and I got to 2. So what number does it look like I'm approaching? It looks like I am approaching 3. This one's asking me to find the limit as x approaches 2 from the right. Here's 2. Here's my right-hand side, so I'm following along this curve, and it tells me my y value is getting close to 1. Now, my overall limit at 2. Well, does my left-hand side and my right-hand side equal? No, it does not, so this does not exist. So there's A, B, and C. Now we're going to go ahead and look at 5, the limit at 5 from the left and from the right. Okay, as I approach 5 from the left, what number does it look like this is? This looks like it is 2. As I approach 5 from the right, my curve is following along. It looks like I'm going to approach 2. Now it's saying, well, what's the overall limit? Do these match? Yes, they do. So since they match, then my overall limit is that number 2. Now some people might be like, that's kind of weird. There's a hole there. You're following the curve. It's not a point. Here's the good question is, what if I had f of 5? I'm actually asking you for the point. What is the point at 5? It is 1. Okay, so limits are different than points. Okay, points are the closed circles, but limits follow the curve. It's saying if I follow this curve as I get to 5, what's it going to be? Okay, so let's be very careful with that. All right, here's some more practice. Notice f of -4. This is asking us for a point. If I plug in a -4, what is my point? See how it's open circle, so not included. There is no point on this one. So actually what we say is that it is undefined. There is no -4. There is no point. So we write undefined. Now we're going to go ahead and look at the limits at -4. This is asking from the left. So as my curve approaches -4 from the left, my y value is 2. As we approach -4 from the right, so as I follow this curve to -4, what's my y value getting close to? It's getting close to 2. Since these two match up, my overall limit is 2. Moving on, we're going to look at 1 at the point 1. So f of 1. So where x is 1, I go open circle, so don't include that. Here's my closed circle, so it's 4. This one has an ordered pair. So it's always asking you for the point. That's notation for you. If you plug in 1, what do you get out? Then we look at 1 as you approach from the left. So here's your left-hand side. So as I approach from the left, my y value is 4. This is asking me to approach 1 from the right. So right-hand side, I follow my curve all the way to get to 1. And my y value is -2. And that's asking me for the overall limit. Are they the same? No, they are not. So it does not exist. All right. Now we're going to go ahead and look at 6. Okay, first things first, what's the point at 6? It's not on the curve. It's the closed circle, so it's when y is 2. Now it's saying as you approach 6 from the left, as I approach it from the left, my curve is leading me to the number 5. As I approach it from the right, my curve is leading me to 5. And then it says, well, what is my overall limit? They match up. They're both 5, so my limit is 5. The next one is your turn. I would like you to pause the video and quickly give these a try. I think it's worth your time to pause it. So pause the video and give it a try. Otherwise, I'm going to go into it right now, but pause it for like 30 seconds, do the problem, then come back. All right, hopefully you took the time and paused it, but here is 3 points again. So you have to find f of -5, f of -2, f of 4. So these are ordered pairs, so where the closed circle is. So -5, I go to -5. This is open circle, so not there, but here is 3. At -2, we got a closed circle, 2. F of 4. Oh, there is no closed circle, so this is one where you say undefined. I know this one isn't on there, but I do want to bring it up. What if I told you to find f of 2? There is no like closed circle. However, do you see how there's a curve here? There is a value. You go up to the curve and over, and so the value is 2. Plug in 2, get out 2. So there's that one. Then we're going to look at the limit as you approach -5. So whenever it's limits, remember we're following the curve. So from the, switch it up, right-hand side first. Here's my right hand over here. So I take my curve and I follow, bumps down here, and I go all the way until I get to -5, and it looks like it's giving me out 7. Then I am looking at -5 from the left. So left-hand side, follow my curve till I get to -5, once again, 7. Limits, you guys are always following the curve. Just make sure you're following the curve. It's not the ordered pair, it's the curve. And then we look at -5, the overall limit. Well, these two match up, so my overall limit is 7. The last thing we need to go ahead and talk about is sometimes there are vertical asymptotes. Okay, so in this case, I would notice that there's a vertical asymptote right here, and it looks like it's when x equals -1. Okay, so what if I asked you to find the limit as x approaches -1 of, we'll call it f of x? Okay, well, if you notice from my left-hand side, this curve is going down, and it's going to keep going down. And from my right-hand side, it's going to keep going down. So if there is an asymptote, it is going to be an infinity. And if you notice, the curves are going down, so it's a negative infinity would be my answer for that one. Okay. If I look at the next little example, there's an asymptote here, and it's at 1, 2, 3, so x equals 3. So if I asked you to find the limit as x approaches 3 of f of x, notice how they're both going up, so we're going to positive infinity. Okay, so that one would be a positive infinity because we're going up. One more I want to quickly just sketch for you. Let's say 5. Wait. Yep, good. There's an asymptote at 5. And what if I have this curve? Whoa, that got crazy. There we go. If we have the limit as x approaches 5 of f of x, are they both going up or both going down? They are not, and so this is actually a does not exist. But we could talk about the limit as x approaches 5 from the left of f of x, and we could talk about the limit as x approaches 5 from the right of f of x. So let's do that really quickly. So since they're not both going up or both going down, it actually does not exist. But limit as x approaches 5 from the left. So this is my left hand, so following the curve, it's going to lead me down. So this would be a negative infinity. If you look at, as you approach 5 from the right, it's going to go all the way up, so it's going to positive infinity. So since one's positive and one's negative, they're not the same. Just because they're infinities does not make them the same. It's like -5 and 5. They're not the same number. They're different. So one's positive, one's negative, and so my overall limit does not exist. Okay, so that is it for limits today. Let me just quickly check on your homework if there was anything I was concerned about that you should maybe take a second with me to look at. Nope, should be all pretty straightforward. Maybe the one thing I would caution is number 15, it is a function that involves sine. So make sure you go your calculator's in radians. Okay, so for number 15, involves sine of x. So mode, it's got to be in radians. Okay, so make sure you do that. But otherwise, you should be pretty good on that. And let me know if you have any questions. Otherwise, have a good day, and I will talk to you later.